Well, hello again, everybody. Happy Sunday. It's Sunday the 20. I don't know. I lost track. Lost track of the days. I don't know. Anyway, I was playing around with some stuff and reading some. I found it interesting about some history, and I came across this blurb about probability and how back in the 1500 BC time frame in ancient Turkey, there was this famine that swept over the area for about 18 years. And so there was no food anywhere. And so people needed to pass the time still they need to do stuff. And so they played games. What they played was dice games. But granted, they weren't plastic dice because plastic hadn't been invented yet. They used actual bones from an animal. Hence the phrase "roll the bones" means roll the dice. And so anyway, my daughter and I were playing around with some dice, and this happened.
3, 4, 5, and 6.
All right, so there are 6 sides on each of the die. What number do you think we'll get? 1, 2, 3, 4, 5, and 6. Let's see what happens. I'm trying. Yeah. What do they got?
1, 1, 1, 1, 1, 1.
Ooh.
Wait, 1, 1, 1, 1, 5, 6.
Okay. Let's see if we can get all. Let's see if we can get 1, 2, 3, 4, 5, and 6.
Okay, we got 2, 2, 3, 3, 3, 6. But there's 3 3s and 2 2s.
Oh, that's kind of interesting. And 1 6. All right. Let's see what we get this time.
Ooh, maybe it's it. 1, 2, 3, 4, 5, 6.
Whoa! We did it! That's
it!
cool. And what you just saw was actually 1.5% chance of occurring. It's pretty remarkable after just a few rolls. But I wanted to play around with that and see how do we get that to 1.5%, and how could we actually figure that out. So let's dig into that. Oh, and by the way, just so we're clear, this doesn't have to do with our circles work or our limits work for my pre-calc class, but it's still just kind of an interesting thing to consider. So here we go. Here are our dice. In this case, there are 6 of them, and we wanted to get 1, 2, 3, 4, 5, and then 6. And we wanted a roll of 6 dice to give us that. In any order, really. I mean, it could have been that, but switched around. But for our purposes, just to keep things clear, we'll just keep them like this. So how do we get 1.5%? Well, let's see. We need to think about how many ways we can get this arrangement or this collection of dice rolls out of 6 die. So 6 dice, excuse me. So on our first dice roll, we could actually pick, there's 6 possible choices that would give us our desired outcome. So there were 6. So let's say it was that one. And the next choice, there are now 5 choices. So that means this is going to be 5. So let's just say it's that 5. And then the third die could be any of these 4 choices. And just to be clear, that 4 doesn't mean that 4. It could be anything. I'm just picking that particular number because it was right there. And then the next die could have any of these 3, so there were 3 total choices. And then the next one, let's say it was that one. The next one was any of these 2, either of these 2, excuse me, proper grammar, Southam. So let's just say it was that one. And then for the last one, there's only one choice. That's it. That's the only choice it could be. So there's one choice. And then how we figure out how many there are is we multiply all these numbers together. So we've talked about factorial before, and this is actually 6 factorial, which equals 720. 6 times 5 times 4 times 3 times 2 times 1 is 720. So there are a total of 720 ways that we could have our dice give us this collection of things, of dice rolls. And just to be clear, I told you that these numbers here don't necessarily relate to the number on the dice. It could have been, because remember, it was we want this collection. We don't care about the order. So for example, our first roll, let's say out of these 6 potential rolls, that there are 6 choices. Let's say it was the 3. Now there are 5 choices, and let's just say it was the 2. And now there are 4 choices left, so 6. And now there are 3 choices left, so let's just say 1. Now there are 2 choices left. Now there's only 1 choice left. That's it right there. That's the one choice we have. That's it. So this is the things that we want. This is how many ways we can get the dice roll that we want. But the way we calculate probability is you divide the desired outcomes by the total number of outcomes. So we need to figure out the total number of ways 6 dice can roll. So let's see. So for the first one, now we care less about these ones. We're going to kind of ignore those for now. Because any die can come up one of 6 ways. So there are 6 possible ways it could come up. But then there are 6 dice. We've got to get up to 6. So the second one, again, there are 6 choices. Any of those 6. For the third one, same thing. Any of those 6. The fourth one, any of those 6 possible number of dots on the dice. And this one, the fifth one, also 6. And then the last one, also 6. And so this ends up being 6 times 6 times 6 times 6 times 6. 6 times 6 times 6 times 6 times 6 times 6. Wow, that's a lot of 6s. And that ends up giving us 46,656. So there are 46,656 different ways 6 dice can roll, but there are 720 that we want. And so if you take 720, divide it by 46,656, we get approximately 0.015, which gives you a 1.5% chance. Oops, forgot the little thing here. Do forgive me, I'm writing upside down and backwards, so there you go. I'm sure there's a way you could do that with video editing, but I don't know that yet. So there we go. So anyway, that's just a nice little fun thing to play around with probability. Kind of fun games and ways to keep our brains occupied. And just how probability works too. There you go. Hope you're having a good Sunday, and hopefully we'll talk sooner rather than later.